So for this next session, I'm going to speak a little bit, and then I'm going to hand over to Aurelio. So I will introduce him first, and then myself. Aurelio?
I guess we could wait for the slides where we have.
You want to wait for that?
Yeah,
okay,
sure.
That's fine. We can do that. I'll do it in a minute. I'll start and introduce myself. In fact, oh, by the way, we both work at Oracle, so you get the pleasure of seeing this slide.
It means,
All right.
yeah, anything about the future, it's just a plan. Don't bank on it.
Yeah, it's the future. And this is sort of another version of our title, which is you can't make an omelet without breaking some eggs. So we're going to talk about omelet making. I am the Vice President of Development for the Java SE group at Oracle. I'm also the chairperson for the OpenJDK Governing Board. And Aurelio is Director of Product Management at also at the Java SE group at Oracle, and was previously at Sun and around working on Java for many, many years, almost a decade, right?
Yeah, that makes me one of the, now I think I'm just shy of being the junior person in the team because we got people that have been there for 15, 20 years, so I'm still sort of new. And
before going over to the dark side of management, I worked as an engineer on Java back, I think I started at Sun in 1996. So I have, there's a lot to blame me for, let's put it that way. And then the third presenter is Charlie Hunt, who actually is Chicago-based, and so we were hoping to have him come by and talk to you. He is on the performance team. He's a performance architect for Java and the JVM. Unfortunately, he was not able to make it today. All right, so some headlines. As you guys can see, everyone is predicting the death of Java. It's horrible, horrible, really sad. Of course, if you take a look at some of the dates, you can see that these were headlines at various releases of Java over the last 20 years. So basically, we have a trend here, right? A bunch of stuff comes along, there's new stuff, it's a little bit scary. Everyone's afraid that the world is going to end. And of course, as we've seen, it hasn't ended. There have been different releases, some bringing more functionality, some less. But by and large, as a development community, we've embraced these and we found ways to both take advantage of the positive aspects they bring and also deal with negative aspects to the extent that there have been those. And the reason that I bring this up is that we now find ourselves on the cusp of a new major release of Java coming, scheduled for July of this year. And this is one of these releases which is not so much evolutionary as revolutionary. This brings the module system for Java. It also modularizes the JDK. And so we're going to talk a little bit today about both that and other things that are in 9 that you may be interested in, as well as possibly a little bit of what we think the future is going to look like. I think one thing that we can definitely predict is that it will take longer for people to adopt Jigsaw because of the fact that the module system brings along with it strong encapsulation. And I think that is something that will be a little bit of a challenge for people to get their heads around initially. We're also trying to do a lot to make that transition easy. I think above all, one of the things that we've tried to do is do all of the development of 9 in the open, in OpenJDK. So you've been able to look at everything that's happening, look at the code, download weekly builds, and we've had a lot of people doing that, and not just people who are interested in JDK implementation or JVM implementation, but also a lot of makers of frameworks and libraries, as well as application developers. So let's go ahead and look at this. What kinds of things is this for? Well, clearly a modern programming language and platform needs a module system, right? I mean, you'd hardly build one today without finding some way of doing that. But of course, a challenge for Java is it didn't have one originally, right? It had a fairly simple way of organizing your code, a pretty simple way of indicating to you, the developer, what code is actually public API that I should be using, or what is something that's meant to be an internal implementation detail, which may be available to other classes in my package, but is not really something that someone from outside is intended to reach in and use. However, Java didn't provide for a way to prevent your doing that. And of course, at some levels, that can be a feature, right? It makes it very, very flexible. It's really convenient to me that I can go and look at a bunch of code that exists somewhere, and I can call it. On the other hand, if you're trying to maintain this as a system over time and evolve it and make it better, it's very, very hard to do that if absolutely anything could be called. And changing it would be considered something, or could be considered something, that breaks users. And so, this is where this desire to evolve and improve sort of comes up against another principle, which we like to think we hold very strongly in developing Java, which is not to break users, right? We want our releases to be compatible. We want your existing code to continue to work. So, the challenge in this case is, how do you evolve something when nothing can change? Well, clearly that's not something that is tenable forever. And in fact, you can go back and look at the documentation from Java all along from mid-90s and see all of the places where it says, this is public API that you can change, that you can use. These other things that are here, you really are strongly discouraged from using. So we'll have a little bit more about that in a few minutes. But I've heard some people sort of say, well, okay, look, I can kind of understand the idea of modules for the JDK, right? For actually modularizing the JDK libraries. But, do we really need to go and extend that to frameworks and to applications? Well, interestingly, a lot of the people that we speak with and many people on the team have, not always just been working on Java, but have actually used it in other programming systems over the years to, to make end user applications. And, one of the things that we universally find is that this challenge that I just described for implementing the JDK exists for those frameworks as well. Right? So if I'm writing a framework or a library, I want to be able to evolve it. But I'm similarly, in a bad state if I can't change anything because everyone is sort of reaching in and dealing with stuff that's internal implementation detail. So it is something that libraries need and want. Even at sort of the higher level, writing an application. How many of you have been in a larger project in your company where all of a sudden you found that something you wrote that you didn't even think about, how to do it, because this is all internal. Somebody else ended up using and depending on, and you changed something without realizing that, and everything broke, right? Happens a lot. So I think that need is there, but it's sort of greater than this as well, because in addition to this sort of encapsulation challenge, a number of the other things that we hear from users is, well, look, we want performance to be better, we want footprint to be smaller, and when we say performance, we also mean startup time, right? So that has been one of the things that people have felt over the years with Java, that we kind of carry around too much stuff, like, do I really need to have Corbo when I'm not using it? Exactly. And in addition, the startup time, which, again, it's wonderful with Java that you have the flexibility of things actually being loaded at runtime, right? And then things starting to compile over time. So with Java, you have both the initial startup, which is the JVM runtime coming up, as well as your file being, being read in and initially interpreted and then over time compiled, as well as all of the things that it's depending on and importing, having the same thing happen there. Now we have had, over the years, a few productive experiments with things like class data sharing and other things that allow some of the stuff to be done ahead of time. But what we really want to get to is something where, when you start your application, it comes up super quickly. Because all of the work of validating classes, of even compiling, resolving dependencies, everything that's done by the class loader magically for you at runtime can actually be done in advance, Okay, so so that's a big piece as well. So as you can see, I think there are a bunch of benefits that the module system brings with it. However, even some of those advantages are also things that could be regarded as disadvantages, right? So a lot of the sort of resolution of dependencies and avoiding ambiguity of which actual version of this class that was on my gigantic class path did the runtime choose for me, right? Now it's pointed out, you're going to resolve that dependency. You're going to have to. And before, you might have thought a system was doing it for you, but you were actually just deceiving yourself. You were lucky if your code got the right one. So there are a bunch of things like that that are going to be interesting to look at. All right, so I'm going to actually hand off now to my colleague Aurelio, who's going to go through a bunch more detail in Jigsaw and other areas.
Thanks, George. I think, yeah, I've got that. By the way, who noticed that the last two in the good section is actually the first two in the bad section, right? Yeah, that's not a typo. That's because for some people that are designing Jigsaw, you don't want any ambiguity. You want to know which class you're loading. There are frameworks that exploit that option and consider anything that fixes that a bug. Likewise, we now have a clear separation of what is intended for you to use and what is intended to be used by the platform, which we think is a good thing, will allow us to evolve the platform. That's probably going to be the hardest pill to swallow for people moving to JDK 9, which is things that they expected to use and were always used to having access to are disappearing. So why is that? It's a bit of background. There's always been a bunch of different categories of APIs in the JDK. There's a couple of them that were supported and intended for use for external use. So there's some Java APIs that are part of the Java specification. You cannot have something and call it a Java implementation if you don't provide those APIs. So of course, developers, that's the contract. That's what we say Java provides. If you stick to that, you can write Java that will run on the Oracle JDK or on IBM's or in any other vendors, right? Because they all have to provide those APIs. Then we have other APIs that were JDK specific. That's Sun, now Oracle. Those are APIs that are only in that product, but that were meant to be used by developers. An example of that is when we introduced JavaFX. It's not part of the Java specification, but the JavaFX APIs, it's meant to be used. If you look at the documentation, it says go ahead and use it. And then there's another set. Those are the unsupported JDK internal, don't touch this, APIs. Those are mostly under sun.star. Okay? There's a couple of sun.star APIs that we think are good to use, but the vast majority of the sun.star are don't touch that. And I mean, you're not supposed to be able to read that, but that's just a screenshot. You can find it with a Internet Archive of a 1996. That's what this little warning from Sun telling you not to use these APIs. As of JDK 6, you get warnings if you try to compile using these APIs. Now, just out of curiosity, how many people here ignore the compiler warnings as a regular part of their day? Come on, fizz up, right? A lot of people, they're just like, oh yeah, it compiled, give me warnings, who cares about the warnings, it compiled, let's run it. You shouldn't, right? There's a reason we put those warnings in there. So when we were considering, well, we have Jigsaw. The truth is we could have just done Jigsaw and not turn on this feature and just leave it so that those internal APIs would remain open. And that would have made the adoption of JDK 9 simpler. And we would just be having this conversation with JDK 10 or JDK 11. So we would just be kicking the bucket for a little later, and we would still be in the same problem. So we've decided, now, we should do the right thing, right? Now that we have a mechanism, let's go ahead and use it. So we went and looked at a bunch of different products. We have the same access that you do to libraries that are open source, and we look at their code to see whether there was indeed some internal API that was required, and maybe we should just make that into a Java SE API. And this is what we found out. You can see that there's a couple of APIs that are widely used, but then what we have is a very long tail of one of two use cases of products. Trivia question, which one do you think is the most used internal API? Anybody? Wild guess? Unsafe. This is, by the way, I love this question because everybody says unsafe. It's not. Base64 encoder. Okay, about twice as much. Well, not twice as much, but that's number one lead. Base64, there's APIs that have been doing this for a long time. There's a lot of external libraries. We introduced a Base64 encoder in JDK 8, and still the most commonly used API is Base64. Just a bit of trivia, when we introduced the Base64 encoder, the official one that's in JDK 8, we have a customer call us and tell us, there's a bug in the new class. It's encoding incorrectly. So, well, what is it encoding incorrectly? He gave us the value, and we're like, no. The original one, the internal one, that's not following the exact specification. We use it to encode a certain set of characters. That character was not in our test case. So the new one does it correctly. The older one has an error. And what was the customer's answer? Could you put a flag so that the new one gives you the same error? So that's how entrenched people are to using these things, right? Well, when we saw this, we realized there's a bunch of internal APIs that are used for convenience, but like the Base64 encoder one, there's quite an easy migration path, right? Use the official one. There are other cases on which, yeah, there may not be a clear migration path, but really, what you're trying to do, it's just such an extreme edge case that we can live without that thing existing. If your code doesn't do that, that's fine. There were, however, a handful of APIs that we found, like SunMISC and Safe, where there's a valid use case for it, and there is no officially supported API that will support it. So if you look at the JEP where we introduced this, we called out, I think it's about 5 classes that we say, those are internal APIs that we do intend to remove at some point, but there's no good answer for in JDK 9, so we're going to leave those exposed. Those remain publicly available, visible. You don't have to pass any parameter. They're still there. Go ahead and use them, with the warning that we're actively working on providing you with officially supported versions for those APIs. When we do, we will remove them. So this is not a new contract. We've introduced them to the standard. That's not what we're doing here. We're just saying, yeah, we need more time for those. Everybody else is going to be hidden by default. And notice I carefully chose the word. It's hidden by default, meaning you can unhide them, right? So, but don't. Okay, it's just a bad idea. But this is going to be the thing that's going to keep most people, that's going to give a lot of grief. Sorry about that, but we think it's the right thing to do. Then we have other changes. And in some cases, anything that we change trips somebody up. One of my favorite examples was, I don't know if you guys heard that Sun was acquired by Oracle. Yeah, it's news. We, of course, went and changed some of the properties. So if you look at the vendor properties of the JRE, it used to say Sun, right? After the acquisition, what would you expect it would say? Oracle, right? It's the vendor property on the file. Who's that going to affect? Yeah, I think it was Eclipse that was going to break if we did that, because they were using the vendor property to decide which startup parameters to use. And they said if it's Sun, it's hotspot. And if it's not Sun, it must be IBM. And it's J9, and it uses different startup parameters. And Oracle is not Sun, no pun intended. So therefore, when we give them the early access build of this, it broke. And we had to provide them. If you look at the JRE now, if you download it, you will see there's a little text file, which has a lot of information, including whether it's Oracle or not. And that's the kind of stuff that would trip us up, right? We think nobody's going to rely on that, and sure enough, somebody does. Similar, the version string. Anybody download the latest version? Well, it's now 31 rather than 21. That's if you do a Java minus version on the 21 version, this is what you get, right? Now, anybody knows what all of those pieces mean? Here you go. The one dot, it's a historical leftover. Every version of Java, all the version strings have always started with one dot. What does it mean by now? Nothing. It's just, well, you don't want to change it because it's always been there. The 8 is the major version. That makes sense. The 0, we had something called revisions. Last time we used it was for version 4. Remember 1.4.2? There hasn't been a revision since, and we don't expect it to ever be. Actually, that's not true. There has been a revision of 8. We just didn't rev the number because it's not such a big deal anymore, right? So we don't try to keep it in sync. So even though the spec of 8 has changed, we didn't change that number. It's still 0. Then there's a non-standard delimiter. There's a number over there that's the update number. And the rule is pretty straightforward. Odd for security, even for features, right? This is a leftover from when Sun alternated, and it was every 3 months, it was like synchronized security release, that's what they called it, and then a feature release, then a synchronized security release. So it wasn't planned, but it turned out that it was odd for security, except that, and then the build number. Except that, it didn't stay there. We decided to do more frequent security updates, so that sort of broke that even odd, but we liked it. So we changed the rule and we said, it will make it end in 5 or in 1 for scheduled critical patch updates, right? And we will keep other odd numbers for unplanned security updates and multiples of 20 for features. And I can see the laughter going. I mean, all of these, each one of these decisions made sense at the time, but once you string them all together, you end up with something ridiculous. By the way, we realized, yeah, we introduced PSU, it's not in 5, it's gonna be in groups of 10. It went completely bonkers, right? So JDK 9, we're ditching this, and we're going for something that is closer to semantic versioning. We provide you an API so that you can use version string and parsing and validation. So the GA version of 9, if you look at version string, it'll be 9, not 1.9.0, blah, 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 blah. Security updates, we have another digit. This is for when we add new features. If a security is all you're doing, you're not adding new features, so that one remains unchanged, 0. And we just keep incrementing this one. We also leave some gaps because there may be a security alert that we didn't plan for, and we don't want to have to renumber everything further out. So after 9, we'll release 9.03. The next planned security update will be 9.06. If we were to do a feature update after 9.06, it would be 9.1.6. Notice that the 6 didn't move because we didn't fix security vulnerabilities. We just added new features. Now, is that a little bit more readable? OK, we hope so. We also found when we were looking at code that would just go and say, well, let me figure out the version number. Delete the first 2, right? Because it's 1 dot. You don't have to. Yeah, it's going to break. Sorry. Also, this means that all of the file names for the JRE and the JDK change. So if you have some sort of automated build system that grabbed the file for you and concatenated things and downloaded the correct one, guess what? Sorry. And in order to add a little insult to it, this is not retroactive, and we expect JDK 8 to be around for a long, long time. So I envision a long future where we have, if version less than 9, this is your logic. If version 9 above, this is your logic. But we think, again, the only way that you stop progressing is if you die. So this is the cost of progress. This is, we have to break some eggs. There's some other subtle changes in JDK 9 that may trip some people up. There's a bunch of tools that we ship with the JDK that are not really to the same level of standard as the JDK itself. In some cases, we don't develop them. So for example, JavaDB, it's just a repackaging of Apache Derby. And it's in JDK 8, it started shipping with JDK 6, I think, or 7. In any case, we're not going to ship it anymore. We figure, now it's not a big deal. Back when we did this, it was a big issue to go and try to download some separate software. And this creates a lot of problems, right? What happens if they rev at a different speed than we do? Are we going to rev just to keep it? Nah. So a bunch of tools are no longer going to ship. In some cases, like Visual VM, we really like it, but we don't maintain it. Our team doesn't, so it just remains in GitHub. Go grab it from there. There's some other experimental tools that we thought, oh, these are cool, but it's kind of hard to keep up with those experimental tools, and now they have better alternatives. So those are going away. And we're also changing a few defaults. Anybody is familiar with what's the default garbage collection algorithm for the JDK right now? And the trivia question is, how many people do you think really care, yet don't specify it and just rely on the default? Yeah, for those guys, they're going to have a problem because we're switching the default, right? And that's going to be G1. Simple fix, don't rely on the default. Pass a parameter and tell it which one you want. But again, some unified login. We don't expect this to be a big issue, but if you were parsing the output of the log, again, you may need to just go and rework it. We think it makes more sense now. And we also have something called a JNLP parsing that was very permissive. If you didn't quite match the spec, we would try our best to guess what you intended. And we've discovered that that's not a good thing to do because we, not always get it right. And you never correct a mistake if you, have this thing fixed for you. So JNLP parsing now, if you got something wrong, I'll just error out and tell you, what do you want me to do? Please provide the right values and I'll work again. Then there's how many deprecated APIs have been removed? We started deprecated with Java 1.2, right? About, I don't know, 17, 18 years ago. How many have we removed? None, right? So I apologize, but that means we've trained developers to think that deprecated is just a warning generator. What's more, we've abused deprecated. There were some swing classes that have a show and hide option, right, to show a form or something. And in Java, we don't like show and hide. So we introduced a set visible true, set visible false. And show and hide were marked as deprecated, not because we ever planned to remove them or because they were wrong, but it's just not as pretty as set visible true and false. JDK 9 undeprecates that deprecation, so it precates them. Okay, so we've deprecated a couple of deprecations. There's also in some cases, there's nothing wrong with the API that's there. You shouldn't worry about it, but there's a better alternative. So if you're writing a new program, you should use the new one. But if you've got some old library that works fine, it's okay to continue using the deprecated one, right? And there's a handful of other deprecated stuff, which is we're just trying to get rid of it, and we plan to drop it in the next version. So even if it's in old stuff, if you wanted to run with the next version, it'd be great if you go ahead and remove it. And before JDK 9, you could read in the documentation one by one, but there was no programmatic way of figuring out which one was which. We've added something called enhanced deprecation, which is an annotation where we say, yeah, this one we plan to remove in the next version. There's a for removal true. And since we all like tools, there's a new tool called JDepreScan that you can run against your code, and it'll find all of the instances of deprecated, and if you pass it the right flag, it'll find the ones that are deprecated with for removal equals true. So you guys are not like the first people to complain about some of these changes. We also have to deal with a lot of people within Oracle that use the JDK, and unlike most of you, they are forced to test it, and they're very vocal about these things. So they tell us things like, just having the compiler tell you that's not enough. I need to have a tool that will work when I don't have the source code, when I'm not going to compile. What happens if I use a third-party library, right? I don't have the source code. I don't know what they're doing. You guys do. Tell me. So there's a bunch of new tools that will help you with this. A bunch of things, as I said, they're gone. Most of them, we don't think, unsupported Apple APIs. They were Apple specific. Now there's an equivalent version that's platform independent. Some GC combinations that were deprecated in JDK 8. Remember those warnings I was mentioning? Yeah, those are warnings on 8. They're going to be errors in 9. So if you see those warnings, do something about them, please. And permgen and things like that. Now, I know nobody here ever would choose to use an internal API, and you are very careful. You don't let any warning pass. However, when we went and looked at all of those open source libraries, we discover, anybody care to guess about what percentage of them used internal APIs? I'm talking about non-trivial code. Anybody thinks more than half? More than half? More than 80%? How about 100%? We couldn't find a single non-trivial library that didn't use internal APIs. As I said, in some cases, it was for some convenience thing. It's not a big deal. But what we expect is, unless you're writing something really small and you're not using log4j or Spring or anything, at least you'll have to rev to the next version of those libraries. So we've been contacting them. We've been telling them, hey, please upgrade these. We're seeing your source code. And we expect that some of them, if not all, will have a version ready by the time JDK releases, JDK 9, and we hope the others will catch up soon after. But in the meantime, I keep reminding people, you are responsible for choosing your libraries. You inherit whatever vices and virtues they have. So it's now on you to ref the library. Likewise, there's a few things that we have deprecated in 9. Some of them we may want to remove later. There's a screenshot of an early access documentation page. There has a whole deprecated section. You cannot really see it here. But there's a long list of things that will remain during 9. You can use them, but you should plan in removing them for a later version. Okay? Another thing that's important, and this is not, well, there's a laundry list of things there. Applets. Anybody needs to know why that is being deprecated? Yeah. Some codecs. Jar, that's grabbing the same jar and running it through jar twice, which for some bizarre reason was supported. It won't be anymore. Other important changes. And this is not just 9, by the way. This happens right now with 6, 7, and 8. Anybody heard about what happened with MD5 as a hashing function? Was a great idea. It's no longer considered secure. What's the next one that's going that way? SHA-1, thank you. So what happens? Your version, you grab a version of the JDK. When you downloaded this thing in 2011, SHA-1 was considered safe. That was the default. You went and you signed a bunch of jars with SHA-1. Guess what's going to happen soon? You're going to have to re-sign that jar, right? So this is one of the few cases in which we go out of our way to tell you with as much warning as possible of a change in security. You don't know what, creating this, the internal brouhaha that it was to be able to publish this. So there's a page, java.com/cryptoroadmap, where we tell you which algorithms are going to be disabled in what version. In some cases, we cannot say anything because if there's a security vulnerability, we'll just do it, and we'll tell you after the fact. But for the ones that we can, we'll set it as far away into the future as possible. We'll give you instructions, if possible, so that you can configure your GRE to behave as it will in the future. That way you can test it and see whether you're infected. And when we do disable the algorithm or something, there are instructions in there for how to turn it back on. That is a really bad idea. It's no good, bad idea. So the only excuse on why you should do that, it's because you were sleeping, you didn't see any of this, you updated, and now your choices are downgrade the GRE, even worse idea, or temporarily configure the GRE to, for example, accept MD5 while you go and resign. I've gotten a few questions from groups about, well, we didn't sign in time, what should we do? Resign. And I mean, either leave the company or sign your jar. Either of those works for me. Okay? So prepare for the future now. All of this sounds a little scary. Plenty of warning, plenty of time. We currently have early access builds of JDK 9, where all of these things that we're telling you are already in place. So if you go to JDK 9 EA, now here's a trick, by the way. If you search for JDK 9 early access, we've recently changed the servers, and as far as I can tell, no search engine has yet found the correct one. So as a stopgap, you can go to the main JDK download page. There's a button that says early access. Click on that one. That one has the updated links I'm sure, all this Google, Bing, they will catch up eventually, DuckDuck, all of those guys. But you can download JDK 9 now, try all of these. We introduced, knowing that what was going to trip everybody up was the hiding of the internal APIs. There's a new tool that's available in JDK 8, and of course, the early access of 9, called JDEPs, Java Dependencies. You run it against bytecode, so I don't care if you don't have the source code, you're meant to run this against your whole project, even the libraries that you downloaded from GitHub. And it'll tell you which modules that particular class uses. There's an option that says, I don't care about the full verbose thing, just tell me about the internal ones, and it'll tell you in advance, yeah, here are the ones that are going to blow up if you try to run this on JDK 9. So you can use it to find the new ones, or at least you'll know which ones to re-enable using that command that we mentioned about how to turn it back on. Okay, you know where my preference lies, find the correct one. So update your own code. As I said, stopgap, use the command line options to turn these back on. And in some cases, you will discover that your favorite library that you downloaded back in 2001 is no longer being maintained, and it's now a good time to go and find an alternative library that does something better. Okay, this is the current page. We have early access builds that we update, I think it's weekly, if not every other week. So the build number is probably off by now, but when I took this screenshot last week, it was 167. We are done feature-wise. So what we're doing now is bug fixes. So if you're the kind of person that waits until it's stable enough because you don't want things to break, you're good, go, get it now. It's got a little label saying developer preview. That means we're in bug fixing mode. You're in the sweet spot where it's not changing, so it's good to check it. But you still have a little bit of a window, so if you find a bug that's important, we might be able to fix it. Please don't be the guy that files a critical bug 2 days before the release. We've been there. We don't like them. You create a lot of problems for us. Give us a couple of months. We'll be very thankful for that. Okay? This is the output of JDEPs, the Java Dependencies Analysis tool, right? As I said, it's in the since GA version for JDK 8, so you already have it. I forgot to ask, anybody here using anything older than JDK 8? Right? And I'm hoping you have plans to fix that soon. Yeah, some people have good reason, but even if you're not using JDK 8, you can still use JDEPs against your code. It's an external tool. You don't have to recompile anything, so that's good. Run it. I run it here against our own TC Updater, the tool that we give you to update the time zones. And you can see that, yeah, we use some internal APIs. And yeah, this is the JDK. We have to use internal APIs. In some cases, we will tell you, you're using this API. Here is the recommended alternative. So if you're using base64, here's the official one. In some cases, we'll say, we have no idea what you should use instead, but just get out of that one. Okay, if you look at the JDK 9 early access one, we have a slightly better recommendations, but they will, either the JDK 8 or 9 will still find all of the internal APIs. And this is my screenshot of that secret command. Well, not secret, but here's what you do. You do add exports. You say the module and which package, and who do you want to expose that to? All unnamed is the automatic name that all code that it's not module gets. So more likely than not, that's the one you're going to get. And you have to do this not at the API level, but at the package level. So you may have to have, as in this case, several instances. And no, we're not going to make it any easier. And yes, we could, but that would be missing the point. Okay? As I said, we have a new development paradigm. We're going to switch to try to get to a faster release model. I'll let George cover that in a minute. We're trying to adapt a lot of new changes that we've been holding back on. So here's some additional tools to adapt to the new paradigm, right? Ahead of time compilation. I think I have a different slide on this one because, yeah, I forgot about the pro tip on this one. So as you know, Java interprets your code, and it compiles it while it's running, optimized for that particular machine. So we figure, could we do that for you and give you an optional step? So we now, with JDK 9, offer the alternative of, instead of you having to compile every single time, you can compile ahead of time. I'm pretty sure I had a little pro tip here at the bottom, which is there's a reason why we don't pre-compile something, for example, the JDK, and put it out there. The reason is because you should really use this on a system that's as close as possible to the one that matches your production environment. Because this thing optimizes for your environment, right? The JDK will produce different bytecode if you're running on a crappy machine with one core and a lot, very little memory, than if you have a monster machine with multi-cores and a lot of memory. So do not be as foolish as to think that you can ahead of time compile it in one machine and then give it to everybody. That's why this is a tool that comes with the JDK. You're supposed to run it on your production machine or as close as possible. Okay? For now, we support ahead of time compiling the base module and experimentally everything else. Okay? So another point that we've heard is, yeah, that's a cool new API, but I want my jar file to work as well with older versions. So that means that I cannot use these new APIs. I cannot use Lambda because somebody may be running it on 7. And I don't want to have a JDK for 7 and a JDK for 8. So since we want to avoid that, we've created the option of a multi-release jar file. In this example over here, if you run this jar against JDK 8 or lower, these are the classes, A, B, C, D. However, if you run it on JDK 9, instead of this A class, use this A class, which will use some API that's only available in 9. And instead of this B class, here's a more efficient way using APIs that are only available in 9. You still have to maintain the code for 9 and 8, but now you can just package it in a single thing and give it to somebody, and it will do the right thing depending on which environment it's running on. I told you I had, see, I copied the slide, and that was the pro tip. So I've already covered this, and the pro tip, use it on your production machine, not on the development one. Okay? Another thing that has changed. We went from one JRE to rule them all to a customized runtime. We did this for embedded, for cloud deployments. The point is, we started this with a use case which was embedded devices, right? Where you have a machine that's not escapable, and we figured, well, do you really need a full JRE if you're only trying to run a very small application, right? The JRE has a bunch of libraries. To your point, it has Corba, it has login, it has a large number of desktop modules. What if I don't need any of that? Why do I have to ship with it? And the paradigm has shifted, right? Back when this was decided, the idea was you're going to have one JRE in your system, and it's going to run every Java application. So therefore, you needed that JRE to be complete, to have everything, because even though you may want to run just a hello world, somebody else is going to try to run some very different Java application, and the JRE must be able to take it, right? And this was to minimize download size. You remember when you had to dial up and things took forever for download? You don't want to have multiple JREs for that. 300 megabytes, that was gigantic, right? You don't want to have multiple instances of that on your system. And serious applications require one large app container, and you set that up and everything runs against that. Now, we're better off minimizing into dependencies. Each application can have its own custom runtime, and I have in my phone 600 megabytes of games and 20 gigabytes of media, right? So 200, that's nothing. And you require hundreds of thousands of instances. So these are the JDK modules. Blue ones are the Java specification. Green ones are some JDK. Black ones are, JavaFX. Black ones are JDK, and there's one incubator module, which is a special module, which means this one is not part of the specification. We're still working on it. Go ahead and try it, but don't build production systems on it because it's not going to be there in the next version. It's going to change, right? We want feedback. My example, these are the Java SE modules and their own dependencies. Imagine that I write an application and I decide, of these, I need APIs that say I want SQL Rosette and Java activation, right? Since those modules depend on other modules, I could create my little graph and say, that's what my application needs. So rather than having a full JRE, which is, I don't know, a couple of 100 megabytes, how about I create a custom runtime? And by the way, let's include my application in that runtime. No need to put it as a separate jar. It's just another module. The whole thing now, it's at 40 megabytes. So I can, since I'm not sharing the JRE, notice that the title has changed. I'm going to run back. Java SE modules. This is no longer a Java SE runtime. This is a custom runtime for your application. It can only run applications that rely on that. So this is what you can do now with JLink and JDK 9. We think this will make a lot of sense when you are trying to create an application in a container that it's self-contained. And now I'm going to give the mic back to George, and let's see if we can come back for questions.
Thanks, Aurelio. Okay, so Aurelio's already started sort of hinting towards a direction that we're going. I think it is important to remember that even with the benefits that the module system brings you in 9, we look at that as not, just the end of a many year process. I think we started, probably 2008 or earlier. Yeah, so that's been running for quite a long time. But we also think that this is really the start of something new, because I think what's going to happen here is the facilities that the module system provides are going to make it even easier for people in the ecosystem to create and maintain libraries over time. And so I think that's clearly something that's been a strength for Java over the years, and this will just make that even easier for people. That along with things like multi-release jars and that sort of thing. And in terms of what you see when you download the version now and you try out these tools, you try out the module system, you try out JLink, is really sort of the starting point. The things Aurelio was talking about with experiments in AOT and footprint reduction and that sort of thing, we're going to be able to do a lot of things over the coming versions that continue down the path of making improvements to that. What we've really done in 9 is sort of shown that that sort of thing is possible and tried to make it good. It's sort of like with Lambdas when we introduced them in 8. Our goal was really to try to make sure that the performance of Lambdas and streams were basically as good as or slightly better than the equivalent if you use the old way of doing things, with anonymous inner classes and fun stuff like that. But basically, we knew that there's sort of a continuing roadmap of things that we can do to make the performance there even better over time. And so we certainly intend to do that. In terms of other things that are coming, I get a lot of people starting to ask me now, well, what's going to happen after 9? And, you can kind of look at this. You'll notice there are no dates on this, but this is just to give you an idea of sort of what the release model looked like, right? Which is a period where we're doing development and early access builds, a period where there's sort of free publicly available builds, and then sort of a long tail of support that exists, usually commercial support from us and from other vendors. And so, that's quite a long period of time, and as you can see, there's a lot of stuff that's being maintained at the same time. Now, on one hand, that's very good. It means that there's sort of stability and predictability. Well, except there isn't always predictability, and one of the reasons is that in the past, for Java SE, there's always been this mode of tying a big driving major feature to a release even before you've started the release. And so we all know now in 2017 as software developers that that's really not such a great idea. That's kind of a recipe for things being delayed or other things happening. And indeed, we've seen that with major releases over the years. And so what we are hoping to do is get to a point where instead of releasing major functionality on a very, very long schedule, we actually have regular releases that come out far more often. And then we work on features in projects in OpenJDK until they're done. And when they're done, they go in, right? But done actually means not, we're going to put it in and then it's going to have 2 years of bug fixing, right? It's like, it's already fixed. We know that the quality is good, et cetera, et cetera. And so, that's sort of a different mode of working. Now, to be fair, we have actually had that mode of working for the update releases. right? So basically, when you saw, I think Aurelio showed the version string before, 8U20, 8U40, 8U60, these are releases that were essentially minor update releases, but had functionality improvements in them, right? And what we're talking about doing now is the same thing, except not only having minor release changes, that is to say implementation improvements, but also introducing new things in the language, new APIs, and more substantial changes in the VM. And so basically what that will allow us to do, I think, is go to a model that is far tighter. And then ultimately, I think what we've seen in a lot of programming communities that have gone to this model is that, rather than doing support for every one of these, there's typically some kind of long-term support type of model, right? Where every few releases, there's something that's designated as a long-term support branch. So anyway, I do want to kind of make it clear, this is something that we're considering right now. There's a bunch of discussion in OpenJDK and amongst people who are collaborating there about that. We're very committed to the stability and quality of Java and keeping that high. We know that's something that all of our users value tremendously. So what we want to do is make sure that if we're going to a more rapid delivery model, we're doing it in a way that's going to be able to help let us keep those core principles strong. And we really think that this shift with 9 and with modules is a very key part of being able to get there, right? Because basically by reducing the security attack area, by reducing the compatibility surface area, and making it possible to evolve the internal implementation because it's far less likely that code out there is going to be depending on it, that will let us get to a point where we can actually validate the changes that we're making are not going to break you and your applications and libraries that you're using. Okay, so basically, I hope that this has given you a little bit of insight into how we think about this, some of the kind of balancing that we do all the time with all the decisions that we make, trying to continue to evolve Java and bring you new functionality. And bring it to you in a timely fashion, not make you have to wait, another 2 years for the next major release, including major functionality, but also smaller things. We'd like to get those in your hands sooner. And we hope that you have a great experience with 9. As Aurelio said, 8 is going to be around for a long time. So if you find when you start using things with 9 that it's a bit challenging, don't stress out about it. You can continue using 8, but look at 9 as, what's coming, how can I take advantage of what's there? So that is it for the talk.